Hi everyone, so today we're going to be talking about osmosis, diffusion, and tonicity. So first, let's talk about some definitions. So we have solute versus solvent. Now the solute is what is being dissolved, and the solvent is what is dissolving the solute. For example, let's say there is water in this bathtub, and we have soap in the bathtub as well. The soap will be dissolved in the water, so the soap is the solute and the water is the solvent. Now let's talk some more about some other definitions. First is diffusion. So what is diffusion? Diffusion is when molecules move from an area of high concentration to an area of low concentration. That means it's going down the concentration gradient from high to low. Diffusion in this case would be when particles move from high to low. Now, what is osmosis? Osmosis is the diffusion of water molecules across a selectively permeable membrane. A selectively permeable membrane means that the membrane allows some particles to pass through and some particles to not pass through. With osmosis, water can pass through that semi-permeable membrane, but other particles cannot. This means that water will be moving from an area of high concentration to an area of low concentration. We can see here that the water is more concentrated in this side of the permeable membrane than this side, which means water will be traveling over to this side. Something to keep in mind is intracellular fluid. In cells, intracellular fluid is the cytosol, basically the inside of the cell. Now let's talk about 3 different types of tonicity. The first one is isotonic. Isotonic means that the solution has the same concentration as the intracellular fluid and the cell membrane will stay intact. You can see here in the before that the concentration of the particles are generally the same on the inside and the outside. However, in the after, it's also the same. This means that through the semi-permeable membrane, the particles aren't moving and the water is not moving because the concentration is the same. Now let's talk about hypotonic. In hypotonic solutions, the solution has a concentration of solutes that is lower than the intracellular fluid. This might cause swelling of the cell. In the before, we see that the inside of the cell has way more particles than the outside of the cell. In the after, we can see that the water from the outside has moved into the cell. It went from an area of high concentration of water to an area of low concentration of water. This makes the cell swell up. That's why it's bigger. Lastly, we have hypertonic. A hypertonic solution has a concentration of solutes that is lower than the intracellular fluid. This causes water to move out of the cell, and the cell will shrivel up instead. As we can see in before, there are way more particles outside of the cell than inside of the cell. It's more highly concentrated outside of the cell. This means that the water will try to escape to make the concentration more even. And we can see that in the after the cell is shriveled up, the concentration is way more even.